Hi everybody, Patrick here from EngineeringShock.com and ElectronicLessons.com. Today I'm going to do an assembly video for a device that I created and posted on Instructables. I actually won a prize in the Wicked Lasers contest at www.instructables.com. I have another demonstration video. This is mainly an assembly video. We're going to assemble this from scratch, and then I'm going to show you how it works. This is what comes with the kit, minus the AC adapter. The AC adapter is too big for the screen, so I'll just go through the components. You've got your custom PCB, 5-volt buzzer, 1N4004 diode, two 2-pin terminal blocks, 5-volt relay, 18-pin dip socket, 18-pin microcontroller dip, 7805 5-volt regulator, LM317 variable regulator, a 3-volt laser, 10 momentary push switches, 2 NPN 2N2222 transistors, 2 2-pin header connectors, 3 0.1 microfarad ceramic capacitors, 2 2-pin headers, a green diode, a red diode, an LDR light dependent resistor, that's our laser sensor, 4 10k ohm resistors, a 240 ohm resistor, a 390 ohm resistor, a 100k ohm resistor, a 47k ohm resistor, and two 470 ohm resistors, as well 11 2k ohm resistors, and 2 100 microfarad electrolytic capacitors. So first of all, we'll do the resistors. Just to show them off, I forgot to mention we also include a siren and a 9-volt 1 amp AC adapter. So we'll get to those later. You may not be able to see the board because there's fine details on the board, but each resistor on the board has a numeration, in this case R20, and a value, 240R for 240 ohms. What you have to do is go through the entire board and determine which resistors go where. Very easy. For instance, R16, 10K. Place one of your 4 10K ohm resistors here. R21, 390R, 390 ohm. Place your single 390 ohm resistor there. 470R, R20. Place your single 420 ohm resistor there. Now, R1, R2, R3, R4, R5, R6, R7, R8, R9, R10, and R12 are all 2K ohm, and it's labeled on the board 2K for 2K ohm. R17 is 10K, R17 10K, R18 is 47K, so you place your single 47K ohm resistor there. R13 is another 10K ohm resistor. It's labeled on the board as all the other resistors are. R19 is another 10K ohm. R15 is a 470 ohm. R14 is another 470 ohms. So you've got 2 470 ohms. So again, you've got 11 2K ohm resistors, 4 10K ohm resistors, 2 470 ohm resistors, a single 100K ohm resistor, a 240 ohm resistor, a 390 ohm resistor, and a 47K ohm resistor. So solder those into place. Be very careful. Resistors do not have a polarity, so you can solder them either way as long as each slot gets the right value. If you don't solder the right values in the right places, you're going to have huge functionality issues. So take care when you're soldering into place. Make sure they're flush to the board and that there's no shorts. The two 100 microfarad electrolytic capacitors have a short lead and a long lead. They go into the C2 and C5 slots. In both cases, there is a little plus sign in the left side holes of C2 and C5. That is your positive. Make sure the long lead of your capacitor is positive, your short lead is negative. Place your short lead on the left-hand sides of the footprints with the little plus sign. Very, very hard to see from this perspective, obviously. And place your short leads on the right sides of the footprint. Now, if you reverse those and you turn on power, you'll pop them and they'll be useless. It might even cause an internal short. Be very, very careful to take your time when placing those capacitors. C4, C1, and C3 are the slots for your 0.1 microfarad ceramic capacitors. There's no polarization there. You can place them in either way. There's no positive nor negative. So solder those into place, and next we'll do our LEDs, our diode, and our LDR. Your two LEDs are placed in the access footprint here and the indicate footprint here. The red LED goes into the indicate footprint, and the green LED goes into the access footprint. Now, you'll notice that both LEDs have a short lead and a long lead, similar to the electrolytic capacitors. The long lead, again, is your positive. The short lead is your negative. The long leads go in the bottom holes. Your short leads go on the top holes. The negative side, the short lead side, goes into the side that has the footprint indicator, so in this case access, in this case indicate. So make sure that red LED goes in indicate, green LED goes in access, and the positive long leads go in the bottom slots, and that the short leads go in the top slots. Now if you turn those around, it won't really affect the functionality of your circuit, aside from the fact that the LEDs will not light up, because current only flows in one direction. Now for your diode. Your diode goes in the D1 slot right here. The diode has a white stripe on one side and black on the other. The white stripe is your negative, the black side is the positive. On the D1 footprint, there is a white bar on the bottom hole on the footprint. It may be hard to see here, but when you have the board in front of you, you'll understand. And the white line on the bottom is supposed to be matched up with the white line on the diode from a bird's eye view. So make sure that your negative, your white stripe, goes in the bottom hole, and your black side goes in the top hole of the D1 slot. If you reverse that and the relay turns on, you'll have a dead short and your system will reset. So be very, very careful. Your LDR, light dependent resistor, goes in the LDR slot right here. There's no polarization. You put it in either way, it doesn't matter, but make sure that it's level with the board and not tilted in either left, right, up or down position. You want to make sure that it's level with the board and is relatively flush down. It won't go down all the way into the board. There will be about 2 millimeters of space between the board and the top of the LDR. That is fine. So just take care in soldering that. And again, with everything, make sure that you don't have any shorts, because if you have shorts, you're going to have problems when you power it up for the first time. So let's solder those into place, and next we will do our buttons and our transistors. Now on to our transistors. The transistors are placed in the T1 and T2 slots, labeled T1 2N2222 and T2 2N2222 for the transistor. The transistors, you'll notice, has a flat side on the front with writing on it and a curved side. Now on the footprints, there's a flat side on the right for both components and a curved side on the left. You want to make sure that from a bird's eye view that the flat side of the transistor faces the flat side on the footprint, which is the case of both transistors on the right, and that the curved side of the transistor is facing left. If you turn those around, your laser circuit and your relay driver circuit will not work. So be very careful to place them in matching from a bird's eye view. Now the buttons. The buttons have 4 pins on each. They fit in the S1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 slots. There's 4 pins per button. Be very careful not to do any shorting when you solder them in. They should pop into place relatively easily. Line up the holes, pop them into place, make sure they're flush to the board when you solder them in for cosmetic purposes. Once you're done doing that, we will do our two 2-pin headers, our terminal blocks, and our socket, our dip socket, and our buzzer. Time for the terminal blocks. The terminal blocks have a side with 2 terminals on them, screw terminals, to screw in wires, and a plastic side. Make sure that in both cases, right here and right here, that the terminals are facing out and not in. The plastic side has to be facing into the board, the terminals have to be facing out. If you solder them in backwards, you're going to have a heck of a time desoldering them, and you're going to have a heck of a time wiring in your power source and your siren. The 2-pin headers are very easy. Place the short ends of the header in the JMPR slots here, and the LAS_EN for laser enable. Now for the buzzer. The buzzer has a short lead and a long lead, similar to the diodes and the electrolytics. In the buzzer slot right here labeled buzzer, there is a plus sign on the right. Make sure that your long lead goes in the side to the right side with a plus sign, your short lead goes in the left side there. Now, lastly, for our socket, and pay very, very close attention, You might not be able to see it, but on the bottom side of the IC1 slot labeled PIC 18F1220, there is a notch on the bottom, and the top is flat on the footprint. There is a notch on the left side of the socket. You want to make sure that the notch faces the notch, which in this case is on the bottom side of the board, when you solder it into place, because your microcontroller, you might not be able to see it, also has a notch on one side, and the notch must be facing the bottom of the board from this perspective. You want to line up all of those little slots, the slot on the footprint, the slot on the microcontroller, in the socket, and the notch on the microcontroller. If you don't do that, if you plug it in backwards, you'll likely fry your microcontroller, and I can tell you, your circuit will not work at all. So pay close attention to that. Now, when you're soldering your socket, make sure there are no shorts. Use a fine-tipped soldering iron. That really goes for everything. Shorts are your biggest enemy, so be very, very careful. Once you've soldered into place, make sure that you carefully place your program microcontroller with the slot facing the bottom of the board into your socket. Once you've done all that soldering, we will do the relay and the two regulators. The two regulators have a front side and a back side. The front side has writing on it, on the black front there. You want to make sure that you don't mix them up. One is a 7805 and one is a LM317. The LM317 goes in the right slot. The 7805 goes on the left. Now, it is labeled on the board, 7805 and LM317. Now, again, if you switch these regulators, you're going to have problems. So make sure that the 7805 goes on the left, LM317 on the right. Now, on the back of the footprints, there's white, and what that signifies is essentially the back of the regulator. So if this is the 7805, you want to make sure that the black side with the writing on it is facing the front, and that the white side, the ground side, is facing, the ground side is facing the back when you solder it into place. So I hope that makes sense. Now, after you solder those into place, what you can do is you can solder in your relay. Your relay has 5 pins, 3 on one side, 2 on the other. It only fits in one way, and it goes in the K1 slot right here. So make sure it's flush to the board. Add a healthy amount of solder to all 5 pins. After this, we're going to run a prelim test, and then we'll hook up our siren. When your package arrives, the AC adapter will have a 5 millimeter jack on the end. What you want to do is cut the jack off. I don't have the unused jack here, but you want to cut that off and strip back some of the black insulation to reveal a red wire and a black wire. The red wire is positive 9 volts, and the black wire is ground. Now, what you want to do is unscrew the terminals from the top, place the red wire. It's nice if you put some solder on the exposed copper on both of them, so that they are what that's called tinning, and it makes the connection stronger. So you want to unscrew the 2 terminals, place the red wire in the left hole, and now the left pin is labeled on the board 12 volts. This board operates at 12 volts, but it operates nominally at 9 volts. So place your red wire in the positive 12 volt pin on the left, and your black wire, your ground wire, in the right pin, which is labeled G and D. Now, you have to pull out your multimeter after this, because what you're going to do is you're going to plug it in. Now, because I don't have an outlet handy, I'm going to use my power supply to simulate the 9 volt adapter. And I'm going to plug it in, and we're going to test the 2 pins over here, laser plus and laser minus. Actually, what we are going to do is we're going to take a multimeter, place our negative probe in the ground terminal, and place our red probe, our positive probe, in the laser plus hole. There's 2 laser plus and laser minus. You want to test to make sure that it's around 3 volts, 3 to 3. Right now I've got my multimeter out set for voltage. I'm going to take my negative lead and I'm going to place it in the GND power supply hole, right there. And I'm going to take my positive lead and I'm going to put it in the laser plus hole right here on the bottom. 3.37 volts, that's perfect. That's what's going to be the power supply that's going to be powering our laser. So if it's between 3 and 3.5 volts, that's perfect. And so now what we want to do is we want to solder in our laser, and that's very easy. Our laser has a red wire and a black wire. The red wire, the positive wire, goes in the laser plus hole, the bottom of the two holes. The black wire goes in the laser minus hole right here. So once you solder that in, it's actually a better idea that you solder them in from the back. So you actually place the wires underneath and solder in from the back side. And that's very important. I should have mentioned that earlier. So make sure you solder it in that way. And then what we'll do is we'll run some tests without the siren and with the siren. Now my laser is soldered in from the back. As you can see, the wires coming from the back. I've got my power supply turned on. And what I want to do is, it's very difficult to see here, but do you remember the laser enable header? You want to take one of your header connectors and you want to plug it in. So once you plugged it in, you can see your laser dot. Now, and you can shoot it across the room and see how big the laser is on the wall, several feet away. Now, what you can do is, it's very difficult to do it here, is you can actually focus in focus in and out to make the laser dot bigger or smaller. And what you do is, when you've found a good focus, you can use a bigger laser dot, like with a larger circumference, but there will be more light dissipated, and the length of the laser will shorten. And if you make it into a dot, the best dot you can, that will be the best focus. Now, if you're going to be mounting this, which I highly suggest, this is the best idea. You want to make the laser as dot-like as possible. Then what you want to do is you want to add some hot glue, just a little bit of hot glue, to hold the focus in place. From there, what you want to do is you want to go from the back. I'm going to unplug my laser right now. After this is solidly glued with your focus, and you want to take some hot glue from the back and put glue all around the laser so that it's right in the middle. From there, what we'll do is we will actually run a prelim test, and then we will solder in or place in our siren. With the JMPR 2-pin header not shorted with your secondary connector, you start off in custom program mode. So you power your unit on, and what you do is you have to program it 4-digit code. Press the buttons and hold it until you see the LED light blink. So I'm going to put in a code of 1, 2, 3, 6. And as you can see, the accept LED started flashing. That's 1, 2, 3, 6. Now that is going to be the code to disable the siren. And so now what we have to do is we have to press the S1 button to place us into lights out mode. And I'm going to simulate lights out mode right now. The accept button flashes, says we're in lights out mode. So the laser will turn on once the LDR senses darkness. And what's going to happen is, if you don't have your laser bouncing off a mirror and back into the LDR mounted very well, then what's going to happen is this. I'm going to simulate lights off. Nothing happened. Now, I didn't actually show the laser. The laser will turn on. I have to press the D1 button, or S1 button again, to put us back into lights out mode. I put my finger over the LDR to simulate darkness. The laser turns on for a short period of time, and what happens during that time is the laser bounces from here, off a mirror, back to the LDR, and if the LDR senses that the laser is there, it will place us into scanning mode, at which point if someone breaks the laser, the siren will turn on. Otherwise, you can disable it by pressing and holding D1. So what I'm going to do is I'm going to place this back into lights out mode by pressing S1. And I know that as I'm obstructing the view a little bit here, I'm hoping you can still see. I'm going to shine the laser into the LDR to simulate this. One beep says yes, it's in scanning mode. 2 beeps says no. So now if I break it, you hear the relay click. Now the relay click means that the siren is running right now. Because we don't have the siren running, I wanted to be able to explain how to turn it off. Now we have to enter in the only code to deactivate the siren is 1236. So I'm going to enter in the wrong code. Beep, 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 incorrect code. 236. Relay turns off and the access LED flashes. So let me try this one more time. What I'll do is I'll place this back into lights out mode by pressing S1, and I'm going to place the laser on the LDR again after I simulate darkness. Now what happens is you turn out the light. Once you have everything mounted, you turn out the light, the laser becomes active, and it does this subroutine searching for the laser to make sure it's there. If it's not, you have to press S1 again, which means you have to mount everything properly. So I'm going to put my finger over to simulate darkness. The laser is on there. I'm going to press S1. And that disables it. And so you're not back in lights out mode again. You have to press S1 to go back into lights out mode again. So, one beep, yes. Siren activated because I broke the beam. 1, 2, 3, 6. Relay off, siren off. And again, what I will do is, what I'll do is I'll show you again lights out mode. If the laser is shot and not bounced off a mirror back to the LDR properly, then it'll go beep beep. 2 beeps and the indicate LED will flash. That's saying it's no good. You have to do it again. In order to do it again, you have to make sure everything's lined up. Press S1 to put it back into lights out mode. Turn the lights off. It'll bounce it back and forth. Now what you might be thinking is, well, that's a lot of trial and error. That's where this jumper comes in, the secondary jumper. Yeah, and you can, once you have everything mounted, you can place that jumper on, and that will keep the laser on for lining up purposes. So you bounce it off a mirror, back to the LDR, and you're off. It's very easy to use. I have a full demonstration video. What I will do is I will bring out the siren quickly, just to show you it in action. But again, I'm not going to be mounting this LED, because if you watch my other demonstration video, it will set the device on the side like this, and you have to mount it. And I'm actually going to be selling these units fully assembled and in kit form with the laser out like this, so you can mount it and focus the laser yourself. So let me plug in the siren. I'd like to mention that the siren has 2 wires, a red wire and a red and black wire. The red and black wire, hard to see from here, has a red stripe and a black stripe. You may receive one that has just black, in which case it's easier to notate. The siren terminal block has 2 terminals. One is siren plus on the bottom and siren minus, which is on the top. Siren plus has the pure red wire. Connect the pure red wire and screw it in using the screw terminal, and the siren minus gets the black or red/black wire. If you place that in backwards, your siren will not work and you could potentially damage it, so take care in doing that. Now, I've placed the jumper on the JMPR slot, and what happens with that is if we power it up, it gives us the default combination of 10, 10, 10, 9. So only 10, 10, 10, 9, 10, 10, 10, 9 will deactivate the siren. Now I'm going to put the siren over here so I can muffle it, because it's very, very loud. So I'm hoping you can see from here. So I'm going to turn it on. Again, I'm only simulating with the laser. The laser should be mounted from the back, pointing outwards and through a mirror back to the LDR, which will take some time in mounting. There are 6 holes, or actually there's more than that. There's 1, 2, 3, 4, 5, 6, 7, 8 mounting holes that you can mount this to a wall or project board. It doesn't come with mounting hardware, but and the siren has 2 mounting holes and has an optional that you can use on the back that it's a double-sided tape. You can rip off the protective coating and just go stick it to something. So right now I have to press S1 to put us in lights out mode. Notice that I didn't have to program in my own custom code there. So I'm going to point the laser at the LDR after I simulate lights out by putting my finger over the LDR. And now I'm going to break it just by putting my finger through it. It's very loud. So 10, 10, 10, 9. Deactivated. So it's extremely loud. Everyone's going to hear it. You'll hear it within several house radius, I imagine. It's extremely loud. Pulsing headache can give you a pulsing headache. So I hope that was a good enough demonstration. What I'll do now is I'll show you what a finished board looks like. So I've wired in the AC adapter. You just plug it in, power's applied. I've mounted my siren using the double-sided tape backing. Again, you can also use 2 holes, 2 soldered in, and I got lazy with mounting. You might have. I didn't have the proper hardware to mount it. Didn't have the right diameter of screws. So what I did was I just essentially glued it to this dollar store box. And on the inside, you'll notice that the laser is mounted. And if you look at the back, it comes out there. So that's it. If you have any questions, please don't hesitate to ask. I will have it available at engineeringshock.com and electroniclessons.com, hopefully by the end of the day today. This is the integration video, so if you're interested in the background of the circuitry, go to instructables.com and find me. My name is Engineering Shock, my profile name rather, and this is my laser tripwire security system. I've just turned it into a kit for everybody. And that will give you detailed details on the schematic. It will give you details on the software. This has been tweaked to so that it has better hardware solutions. I've optimized hardware and I've optimized software. So it's very similar to that one, with slight differences. Thanks for watching, everyone.